Welcome to the damped pendulum video. In exercise 1 of this experiment, we'll be setting up an aluminum pendulum and measuring its undamped frequency.
Hang the rotary motion sensor from a stand and attach it to the data acquisition interface. Ensure that the plastic pulley has the large side out so that you can wedge the pendulum arm into it. Adjust its height such that the bob swings through the center of the magnet.
Open Data Studio and click Create Experiment. Click the first digital channel and select Rotary Motion Sensor. Change the sample rate to 100 Hz. Create a graph of angular position versus time. Move the magnet out of the way to measure the undamped oscillation of the pendulum. With the pendulum at equilibrium, press Start and set the system in motion, and record a sufficient number of oscillations to answer the questions in the manual.
Measure the length of the pendulum. Note that it may be appropriate to use the edge of a table to measure the pendulum's center of mass and consider the length from there to the pivot.
Also, measure the mass of the pendulum.
In exercise 2, we'll be setting up an underdamped system and measuring the damping coefficient.
Place the magnet around the pendulum bob. Unscrew the magnets as shown, such that the bob swings through in an underdamped fashion. You may use any or all of the pendulum bobs for this exercise.
In Data Studio, click Setup, check the angular velocity box, and create 3 graphs: angular position versus time, angular velocity versus time, and angular velocity versus angular position. Press Start and set the pendulum in motion. Record until the pendulum stops, and repeat with other bobs and/or magnet separations.
In exercise 3, we'll be setting up a critically damped system and measuring the damping coefficient.
Adjust the magnet separation until the pendulum oscillations appear to be critically damped. I recommend getting it close with your eyes and using the computer for the final touches.
Once again, press Start in Data Studio, set the pendulum in motion, and capture data until it stops. Compare the damping coefficient to the theory and also to the underdamped coefficients calculated in exercise 2.
If you broke the law of gravity, would you get a suspended sentence?